Welcome to Projectile Motion. In this lesson, we'll look at a few key ideas, but the biggest one from this slide I'd like to point out is that by the end of the lesson, I really want to make sure you know that time is what connects the horizontal and vertical directions. Let's begin. To describe projectile motion, it is motion in which an object is moving in both the x and y directions under the influence only of gravity. Two key words that we'll need to understand that it's different from two-dimensional motion: trajectory and range. Important key points is that we must keep the x and y components separate. They are independent of each other, except for time, and we'll look at an example here in a second. Except for time. Time is what connects the x and y because time is continuous. In the y direction, we know gravity is negative 9.81 meters per second, and velocity at the highest point is 0, unless it's been thrown down and that sort of thing. If an object is thrown from the top. The x direction, the thing that we're going to add here from the previous lesson is that the acceleration in the x direction is 0 meters per second squared. So that's going to come in real handy when we start looking at this example here. So here it goes. A projectile is fired with the initial speed of 10 meters per second at an angle of 30 meters per second above the horizontal. What is the magnitude of the horizontal component of the projectile's range if landed in the same height? All right, so we'll look at this and go through this problem. The one thing that is making sure I know is what is the x component. So I'm looking for this final position of x. Go over and label my drawing. My initial velocity being 10 meters per second at 30 degrees. Based on the information from the previous slide, I know that I want to make the initial position for my x 0, making my y initial also 0. And since it lands at the same height, my final position for my y is also 0. I know that my final position up, or final velocity up is 0. My initial y down is 0. My acceleration due to gravity, negative 9.81, in both the up and down. My acceleration in the x direction, thanks to the previous slide, is 0. Well, that's basically all the information that I can infer about the problem. Now I can calculate the initial velocity in both the x and y, so let's do that real quick. And since I know that the y velocity is that the y position starts and ends at the same point, so there is no displacement, I know that the final velocity down is opposite and equal to the initial velocity. Okay, there fills in some more, and so in the x direction, so if there is no acceleration, I can also know that my final velocity in the x direction is going to be 0.866. Okay? Now, understanding where we need to go next, all right, I could look for my final y. I need my time in both the x and y, and I need my final position. So we've almost filled out this whole chart when we're looking at the parabola, looking at that arc that this projectile will make. Now, what I would like to do here is I actually would like to solve for time. And so I can simply use the up for now. Actually, let's do it all together since they end together. We can actually combine these, that my final position is negative 5. So that would give me the time for each up and down, 0.51 seconds. So the total time would be 1.2 seconds. So that would be my time for my x. Sorry. Got a little ahead of myself. Alright, now using this time, I can use the x final equals x initial equation to figure that out. And so I'm going to do that for you now. Alright, so our answer is 9 meters when we include significant figures. Alright, so I'm just going to want to take a few seconds to explain this slide and just kind of make sure we have a good visual representation of what is going on with velocities as we travel through this parabola. And so if the ball travels this parabola shape, all right, from this option, all right, from P, Q to R, all right, what's happening with the velocities? Now, because the velocity in the in the X direction is 0, then my velocity is a nice even straight line. In the Y direction, because I have acceleration, it's the only thing acting upon it, I have this going on. Alright, I have a positive acceleration finally entering to 0 in the Y direction to Q, and then decreasing all the way down. Alright, and so it kind of shows you the difference, and that'll kind of help you see mentally what's going on with the velocity, so as more problems come your way, you can actually visualize what's going on graphically. It'll help you do a little bit of your math. So last thing I want to make sure you know is that if I have horizontal projectile motion, which means simply that there is 0 meters per second in the Y direction, there is no initial Y, alright, so there is no theta. I want you to know that basically half your work is done for you, okay? And so it's the same process as you've been solving them. It's really simple. It's just half the work, and your total time in the Y is your total time in the X, because it's only half the parabola. And so there at the bottom you'll see that there's 3 common types of the cannonball being shot out of the cannon, gun being shot horizontally, balls rolled off the table, all sorts of those things. 0 theta. Alright, I'm only doing about half the work. Good luck.